Jai Hind to all. Myself Dr. Nilesh Kumar Gupta. I am working as a professor in EC department at Ajay Kumar Garg Engineering College, Ghaziabad. So, today I will deliver a lecture for a subject of information theory and coding. Its AKtU code is KEC 075 and the title of my this lecture is Inequalities in Information Theory. So, last time I almost finished information theory. Now, in this lecture I will discuss about the inequalities. Some inequalities are there in information theory that I will tell you. Okay. So, let us recall. Lastly, I told you about the mutual information concept. What is the mutual information? It is the trans information between the two random variables or between the transmitter and receiver in communication system. Because ये सभी हम पढ़ क्या रहे हैं in the respect of communication system. Okay. So, the concept of mutual information and also I told you the some examples for calculation of mutual information and the relation between the entropy and mutual information. So, all are correlated. If you know the some entropies for the channel, you can calculate mathematically easily the mutual information. Okay. Then I told you about the relative entropy, the concept of relative entropy. कि relative entropy क्या होती है? Relative entropy क्या होती है? That also I told you. So, relative entropy concept also I told you. Okay. So, this I finish till my last lecture. Today we will concentrate mainly on inequalities in information theory and their importance. Now, again one thing also I am telling you, okay, the chain rule for relative entropy. So, last time I discussed about the relative entropy. What is the relative entropy? मैंने आपको बताया था relative entropy क्या है. It is represented by D is the notion. Okay. तो यदि कोई दो वेरिएबल हैं P x and P y Q x sorry P x and Q x. So, you can determine relative entropy those two probability mass or distribution function. So, this is the one chain rule, okay, between the some distributions. Like what it says the relative distance entropy between the Pxy and Qxy. This is the symbol of relative entropy. So, it will be equal to d distance between the relative entropy between Px and Qx plus Py by x and Qy by x. So, let us prove this. So, हम कोई भी एक टर्म लेके चलें, यहाँ का हम लेके चलते हैं d Pxy and Qxy. So, by the formula in last lecture I told you about the formula. So, it will be summation x y because it is two dimensional Pxy log of Pxy upon Q of xy. We know Pxy is equal to क्या होता है P y by x into Px. Similarly, Qxy is equal to क्या होगा Q y by x into Qx होगा. तो यहाँ पे हमें वही पुट कर दिया Pxy is equal to Px into P y by x. ऐसी Qxy is Qx into Qy by x. I am putting the formula here of probability matrix. Now, we know log m into n क्या होता है log m plus log n. So, here we are segregating log m plus log n. Now, this is what? It is equivalent to the relative entropy between the Px and Qx, and this is related to relative entropy between the P y by x and Q y by x, and hence proved. So, in this way easily you can prove the chain rule for relative entropy. This chain rule also we can prove, we can see for entropies and another parameters that I told under the information theory, but this is especially for relative entropy. Similarly, you can another type of chain rule for relative entropy prove here in the very similar and simple and systematic way. Okay. Next. Now, concave and convex function. Because I am trying to come what on inequalities. For inequalities, some functions, some mathematical terms that you should know. So, concave and convex function will come those categories. Okay. A function f of x is said to be convex over an interval from a to b if every x1 x2 that will be between the a and b, then it will be set convex function for the value of lambda from 0 to 1. Next, a function is convex if it always lies below any chord, and it will be concave if it above any chord. Now, some examples of convex functions are x square, mod of x, e of x, x log of x for x is greater than or equal to 0, etc. So, these are the some examples, mathematical examples of convex function. Actually, everything we can verify, okay, or derived mathematically. तो कम्युनिकेशन सिस्टम जो हम पढ़ते हैं मतलब वो तो ठीक है, सब मेथड्स हैं, बट दीज ओरिजिनेटेड फ्रॉम दिस दैट वी आर डिस्कसिंग, वी आर सीइंग इन इंफॉर्मेशन थ्योरी. सो दिस इज द बेसिक एंड हार्ड पार्ट ऑफ बेसिक एंड इम्पॉर्टेंट origin part of communication system, that is information theory. Okay. Now, examples of concave functions include log of x, root of x for x greater than or equal to 0. So, here I am giving some examples of concave and convex function, okay, that also you can refer for a study of information theory. Now we are coming on inequalities in information theory. What is the meaning of this? Inequalities. In mathematics, an inequality is a relation which makes a non-equal comparison between two numbers or two mathematical expressions. So, it is like a non-equal comparison between the two numbers or two mathematical expressions. It is used most often to compare two numbers. Inequality मतलब क्या है कि हम किसी दो के बीच में कुछ चेक कर रहे हैं, कुछ कंपेयर कर रहे हैं on the number line by their size. So, we are comparing something, okay, and this is non-equal comparison. Information theory provides fundamental limits on data transmission and storage. Okay. So, that you have to keep in your mind. Now, again continuously we can see these points regarding the inequalities in information theory. Most of the achievable limits are thus stated in the form of inequalities involving fundamental measure of information such as what? Entropy and mutual information. That I told you in my last lecture in detailed form. Now, inequalities are also very important in the study of information theory. That also I told in my last lecture. The inequalities that we will see here in terms of some theorem, these are also very important for study of information. And there are number of different contexts in which these inequalities appear. So, we can see there are several number of inequalities that we can see in terms of information theory, and those are very important. Now, firstly, if we see Jensen's inequalities, okay, Jensen inequalities. If f is a convex function and x is a random variable, okay, then as per the Jensen inequality, what E of f of x will be greater than or equal to f of E x. E मतलब क्या होता है? This is expected value, average value you can say. So कोई function f of x कोई convex function है for random variable x. So E or expected value of f of x always will be greater than or equal to f into E of x. This says by the Jensen, and this is our Jensen's inequality. Now, we can prove this Jensen's inequality also for discrete distributions by induction on the number of mass points. The proof of condition for equality when f is strictly convex function will be left to read. If we consider two mass point or two probability mass functions distribution, then this Jensen inequality becomes क्या बन जाएगी? देखो दो हैं तो P1 fx1 plus P2 fx2. P1 P2 are the corresponding probabilities will be greater than or equal to f of P1 x1 plus P2. It is like a superposition law, you can see. If you are considering this Jensen equality for two mass point distribution, then this inequality becomes in this form. So, this says by the Jensen's inequality in terms of expected value of any convex function for a random variable of x. Next, we can see here log sum inequality. So, log sum inequalities, it is for non-negative numbers, it means positive number like a1, a2 up to the n and b1, b2 up to the bn. So, as per the log sum inequality, what summation I1 to n ai log of ai upon bi greater than or equal to what summation of I1 to n ai log summation I1 to n ai I1 to n bi with equality if and only if ai upon bi is equal to constant. तो यदि ai upon bi ये constant हैं, okay. So, for the as per the log sum inequality, this type of expression will be there, okay. It is very simple, it is very simple inequality actually. Now, by the log sum inequality, what we can write here? We know the relative entropy between the P and Q, that is the formula we know here, summation P of x log P x upon Q x. Now, it will be greater than or equal to summation of P of x log of summation P x log of summation Q x. Now, if P of x is equal to Q x, it means it is 1 by 1. So, it will be equal to 0. So, this equality log sum if and only P x upon Q x is equal to C. Since P and Q are two probability mass function, if C is equal to 1, it means P x is equal to Q x, then our relative entropy also equal to 0. So, also we can correlate, we can compare, we can equate this log sum inequality in terms of relative entropy between the two probability mass distribution or functions. So, if P of x is equal to Q of x for all the value of x, our log sum inequality value you can say or relative distance between the two probability mass function will be equal to 0. Okay. So, that also you have to keep in your mind. Okay. So, this is our log sum inequality. Now, next is our data processing inequality. ये क्या होती है? So, data processing inequality बोलती है if random variable x, y and z are said to form Markov chain in that order denoted by x tends to y tends to z. If the conditional distribution of z depends only on y and it is conditionally independent of x, especially x, y and z form a Markov It means x tends to y, y tends to z. if the joint probability mass function can be written. तो उसका joint probability mass function होगा, it means x y z के term में वो क्या होगा, it will be p x y z is equal to p x p y by x into p z by y. So, one individual probability matrix and two conditional probability we are taking here, okay, as per the data processing inequality. In this x tends to y, y tends to z, if and only x and z are conditionally independent on given value of y. So, Markov implies conditionally independence of random variable, that you have to keep in your mind and remember all the things. Okay. Okay, this is our what? Data processing inequality. Okay. So, as per the data processing inequality, that you have to keep in your mind. Okay. Now, as per the data processing inequality, our mutual information between the x and y, okay, it is greater than or equal to mutual information between the x and z. Similarly, one can prove that I y z is greater than or equal to I x z. So, it depends upon Markov chain that we are preparing, we are making here, and also we can analyze about the mutual information between the two variables. And this type of conclusion, this type of result or consequences we can give here. Now, this inequality can be used to show no clever manipulation of the data can improve the inferences that can be made from the data. So, that also you have to keep in your mind. So, this is regarding the data processing inequality. Okay. Next is our Fano's inequality. ये क्या होती है, ठीक. So, Fano's inequality generally shows the loss in information theory, कि general में loss in terms of some entropy, conditional entropy. So, always we have to refer the loss in information theory in terms of conditional entropy. So, Fano's inequality is very important. It relates the probability of error in communication system. आप जानते हैं, in communication system, in digital communication, because generally we are not using nowadays analog communication, we are using the digital communication. So, here our error, bit error rate, probability of error. So, error always we show in terms of probability of error. So, mathematically in terms of channel, in terms of information, this probability of error in guessing the random variable x will be given in terms of conditional entropy, that is h x upon y. So, हर एंट्रोपी का अपना अपना फिजिकल सिग्निफिकेंस है इन टर्म्स ऑफ इंफॉर्मेशन थ्योरी, दैट यू हैव टू कीप इन योर माइंड. सो एच एक्स अपॉन वाई जनरली शोज द प्रोबेबिलिटी ऑफ एरर in terms of conditional entropy in information theory, and that was given in terms of this inequality theorem given by the Robert Fano. So, this inequality relates the average information loss, कुछ information loss भी होगी, तो that information loss we can give by this entropy, that is h x upon y in a noisy channel to the probability of categorization error, and it is given by the, it was given by the Robert Fano. वैसे भी h x upon y का मतलब क्या है? If we understand here, h x upon y means the entropy of x or the entropy of transmitter with respect to y. तो entropy transmitter की हम जब देख रहे हैं जब y से कुछ रिसीव हो गया, तो ये तो अपोजिट केस है, लॉस ही है, उल्टा केस आ रहा है. बिकॉज कोई चीज़ रिसीव होती है एच वाई अपॉन एक्स होता है. सो दैट विल बी द एंट्रोपी ऑफ वाई विद रिस्पेक्ट टू एक्स, दैट इज फिजिकली रियलाइजेबल, फिजिकली पॉसिबल, बट एच एक्स अपॉन वाई इज नॉट फिजिकली रियलाइजेबल और पॉसिबल. दैट्स वाई एच एक्स अपॉन वाई ऑलवेज शोज द व्हाट average information loss in information theory or in our channel, okay, for a communication system. Okay. So, that concept was given by Fano, and this we can understand by Fano's inequality. Okay. Now, we know that the conditional entropy of a random variable x given another variable y is 0, if and only if x is a function of y. Hence, we can estimate x from y with 0 probability of error if and only h x upon y is equal to 0. सीधी सी बात है, if h x upon y is equal to 0 आएगा, it means there is no information lost in channel, everything is okay, कोई loss नहीं हुआ, सब बढ़िया हो रहा है. Some data that we are transmitting from transmit receiver, that will be perfectly received at the receiver. It means there is no loss, no probability of error. Okay. It means our h x upon y entropy will be 0. Okay. That you have to keep in your mind. Now, but we expect to estimate x with low probability of error only if the conditional entropy h x upon y is small. सीधी सी बात है, यदि h x upon y जितना कम होगा उतनी probability of error क्या होगी, कम होगा. हम ये बोल सकते हैं अब आगे क्या कि h x upon y it shows the loss in average information of the channel and it shows the probability of error. If its value is low, less, then it shows low probability of error in communication system. So, it signifies the information theory. Fano's inequality quantifies this data, it quantifies this. Okay. It defines the probability of error. तो probability of error यदि हमें चाहिए, if we are discussing, we are seeing here what? Information theory with respect to communication system. So, always we can give by using what? This entropy, that is h x upon y. So, in this lecture what I told you? I told you about the inequalities, the role of inequalities in information theory. All the inequalities plays very important role, very important part for information theory study. These are very very important. और सबका अपना अपना क्या है यहाँ पे importance है. Okay. Like I told you about the Jensen inequality, then log sum inequality, then our Fano's inequality, then data processing inequality. Inequality is what? Inequality क्या है? Inequality is a non-equal comparison between the two mass functions, two mathematical expression and so on. So, इस तरह से हम inequality को defined कर सकते हैं for information theory, and each inequality theory plays different and important role that we have to understand here. These are the references, okay, that we can use here. Okay. So, from this lecture I covered your basic of KEC 075 or that your AKtU subject and the contents available in unit number 1, okay, regarding the information theory, entropy, mutual information and inequalities, that I covered till this lecture. So, you can understand about the information, entropy, your mutual information, inequalities, relative entropy, chain rule, the some examples or mathematical calculation by which you can determine the entropy, information, mutual information and so on, that you can understand here. Okay. So, in this way I am concluding this information theory basic here. In next lecture, I will start about the source coding. Ki after the information, okay, you have to encode your source. Okay, encode your source. Okay. So, thank you very much. Goodbye.